Hello, and welcome to ToMakeItGo. Um, in this episode, I am going to do something a little bit different than what I've been doing. I think I'm going to build. Well, I am going to build. Well, I will attempt to build a DSL for rolling dice. And if we get to the end, I'll fire it into my and write it up as a front-controlled gateway endpoint and allow traffic to route to it. But for now, let's just get some simple idea of what I want my language to look like and how I'm going to lex and parse it. This is just going to be a simple text file because it's going to be something that has just a rough look at my language and a couple of examples. So let's explanation. That's not how you spell that. That's still not how you spell it, but I'm just going to create it so that, yeah, I feel like I'm, example. Okay, so I'm going to use dice notation, which is something that looks like this. 1d4 plus 1. Sure. We're going to ignore white spacing. There you go. So that would say roll a 4-sided die and add 1 to the result. Okay? Then there's also stuff like 2d4 minus 1, which would say roll 2 4-sided die and add, or actually more appropriate, roll a 4-sided die twice, summing the results and subtract 1. From the sum. Summing. But there's 2 2s. Summing. I don't know what that is, and I don't know why IntelliJ suggested it. But okay. So, there we go. And of course, you can do whatever you want in this notation. So you could be like 1d4 plus 1d6 plus 1d8 plus 1 minus 1 plus 2. With various spacing. So that would also be an example. Okay. Also, just to have simple simplest expressions. 1. We'll put those at the top. 1, 2, 1, 1d4, and so on and so forth, and like 1 plus 1, 1 minus 1, and so on and so forth, and it would just do the arithmetic that you would expect. And that is all I think I will. That's the language I think I will attempt to build. I don't particularly. This would only be helpful if you want to play a tabletop game of some sort. So, let's start by identifying the parts of speech of my language. So, I have a die, which is N D Y, with, actually, I'll make these integer. So it's integer followed by D, a D uppercase or lowercase followed by integer. I have a integer which is, for simplicity's sake, I'm going to say 0 through 9. Plus. So it has to be at least any number of 0s and 9s. Which means, technically, this is allowed. 0. You ask to roll nothing, it will return you nothing, which makes sense. Good sense, in my opinion. Okay, then I will also have a plus, which is just going to be defined as plus, minus, which is going to be defined as I should probably, I'm going to single quote those because they're characters. That's a regular expression, you should be able to figure that out. So, integer. Okay. So, those are my lexical rules, or at least my tokens. So I have a die token, I have a minus token, a plus token, and an integer. So those are the things I'll need to be able to rip apart and put into some sort of stream. So my language looks like it will have, because 1d4 and a 0 are really a unit of some sort. I would like to call them, I'm going to treat a die as a number. So a number is anything I can evaluate. So number is defined as a die or an integer. Okay, that's well and good. So then we have number expression, which is going to be a number. Well, first we'll have to find an operator. Operator is defined as plus or minus. Let's move that up here. There we go. So what I'm writing is a weird hybridized EBNF. A version of EBNF. I'm not sure that it matches all of the criteria to actually be proper EBNF. But it's pretty good for the spur of the moment decision to write a DSL. So you'll get, that's the best I can do. I think to handle this, I'm just going to lowercase everything. That comes up later. So now we have an operator, plus minus, number, die. Okay, so then we have a number expression, which is going to be a number followed by an operator followed by a number. Or I'm just going to put those down there so it all looks like a thing. Okay, so that's number, operator, number, or a number, operator, followed by a number expression. Oh no! Okay, so that's the language I think I'm going to. There we go, quick dirty analysis of dice notation. I will call this dice notation, because I believe I am close enough to the Wikipedia definition of dice notation that I will just be safe. So we have dice notation. So now I will need to build a lexer to identify my tokens and to generate a token stream. And then, well, just generate the tokens. So I'll blow it apart into tokens. So I'll take a string, blow it apart into my individual tokens, and I will match them up against the rules. And then from that I will, step one, let's build a semantic model. Yes, always start with your semantic model. I'm getting ahead of myself, but this is my end goal: be able to parse something that looks like this. And number expression. Oh, there's one small issue. A number expression can also just be a number. So we have a number, number operator, number operator, number expression. There we go. So that will match this case, this case, this case, this, all the way down. Okay. Notice this is a right recursive definition, which means I should be able to do this relatively easily. I won't have to do any of that crazy monkeying about with making a left recursive grammar or right recursive grammar, because that'd come up later. So there we go. Also, I have something called die. I could make it die, but that's just not spelled. I can make it this die, but then it's just misspelled. Okay. So step 1, let us build my lexical structure, or my semantic model. So from this, I will notice that I have something called a number. I will have something called a number and an operator. So we'll have operators and numbers. I'm going to call it D number. Haha, D number. I'm not going to call it number because number exists in Java and does not mean any random. It does not mean to evaluate a random string. Okay. Step 1, let's create a number expression. We're going to make that an interface. So a number expression will have a static class in here. Evaluation result. Because you're going to be able to do one thing to a number expression. You're going to be able to evaluate it. So, evaluation result. Eval. Okay, so we have a number expression. It has an actually, I'm going to just call it evaluation. There we go. This will have an integer of just a number, value, and it will have a string of a description. Description. Those will be private. And we'll make them final too. Yeah. Construct them. And then we get getters for them. Okay, so then the simplest object to build is Java class D integer. So you're going to implement number expression. Actually, we're just going to take an int, because I'm not going to have it have null. Yeah, this doesn't get to be nullable. Because I don't want to deal with that. Value. We'll just construct it with a value. You will return value, comma, string dot value of value. That's straightforward, simple enough. I don't particularly feel like testing that. There's no particular reason to. It fits on a single line of code, or it is a single line of code, and it takes an integer and wraps it. I already know that Java's integers work, so there's no particular reason in testing it. Then we are going to have a D die. D die. Die. It's also going to implement number expression. Okay. So now it takes an int number of rolls, int number of dice sides, number of sides on die, and we're going to make an interface for a random, because I want to be able to mock out my randomness when I eventually go and test my higher structure. That way I could test larger expressions and know that they're doing the correct thing. So let's make that interface. Public interface, roller, die roller. It's going to return an int roll, and it's just going to take number of sides. Okay. There we go. By the way, I'm not doing this at all test driven, so you can notice that. Okay. So now eval. When I eval this, I think this is construction arguments. I need one of these guys. Die roller, roller. Take all three. So now, for I number of rolls, int result, we'll change it to 0, and we'll have string, so description. Okay. So then, step 1, roller dot roll, number of sides on die. Current roll, take current roll, result plus equals current roll. Okay. Then we're going to say if I equals 0, not O. Result description plus equals current roll. There you go. This is something that probably deserves a test, but then we'll return that. Okay. Deception. Description. There we go. Okay. There we go. So now let's test our die. Because I just did some formatting nonsense. And I'm going to do a little bit more. Okay. There we go. Well, before we continue, I also have operations. Plus. Okay. Plus takes a number expression left and a number expression right. So it's the plus operator. Excuse me. Sorry about that. I had to cough, sneeze. Okay, so the left-hand expression and the right-hand expression, and it adds the two together. So now, then, I'll take those point construction. Let's actually just put this logic into evaluation. I don't know why I type exception. My mind's playing tricks on me. So then this dot value equals left dot value in value plus, and then this dot and let's put a space in there. Okay. So this will tell us how we arrived at our number so that you get an idea of what the rolls were. Okay. So plus just takes left dot eval, right dot eval. There we go. And then the only problem with this is I can't put that in there. I can't put that in there because minus is identical to plus. It just uses a different operation, and then left side, right side. Okay, so this is and this is left side dot get description. Okay. Then we build minus in the same manner. Ta-da! And I'm actually just going to go grab verbatim plus because it is identical except for the operator I shove in there. And this is a minus operation. Let's bust these down. My line's a bit too big for my taste. There we go. And I need a construction. Okay. So then, now, that's about all there is. So let's write a couple of examples of using this. So, just single test. Ooh. Die. One roll of one. And we're just going to return twos. I loaded die. Temperature evaluation. Evaluation dot get value. That should be 2. A single roll. There we go. And I'll be 2. There we go. It is in square braces. Good catch. There we go. And I'm just going to make this a function so that I can call them over and over again. So this is going to be expected value. This is going to be expected description. That's actually one roll of D4 because one-sided. Yeah, my test said on a one-sided die I got 2. That's a bad number generator. Okay, there we go. Control V, number of rolls, number of sides. I'll move this down. Fix my spelling error. So insert roll. None of these. So there we go. Then 2 rolls should be 4, and this should be 2 space 2. Zero rolls should be empty and 0. Not the most exciting thing, but there you go. Let's go with 3 to continue the pattern, so you can be all like, yeah, I get it. 2, comma 6. So I actually want to say 0D4 because I want you to know what happened. 2D4. So that's just going to be a simple change. There you go. That's what I expect. Okay. So 0D4 value, it's that. There we go. That's that. Let's go write a test for plus. If you're criticizing that all of my methods start with test, yeah, I don't particularly want to be creative because plus is a function and there is only one test, and that is to test plus. It could be like test plus given values adds them together in the expected manner, but you'll have to forgive me for my bad name. New plus. So new, we're going to make these integers 1, 2, left. That's actually right. This will be left. Left, right. Dot eval. Result. Assert that result dot get value is, in this case, it is 3. Description is 1 plus 3, or 1 plus 2. And there we go. To do it, let's make it fail so I can see it fail. Well, lucky at that. Let's make these number expression. expected sum. Expected. My timer's going off, so it's been a half an hour, so I can't quite wrap everything up. I have built my entire semantic model for this. Now I just have to figure out how I want to parse or how I want to take my input. Description. And to write a couple of quick tests around this to make sure that it behaves how I expect it. Thank you for watching this episode of To Make It Go. I will see you again.